sentences into algebraic expressions. This section in particular is one we need to pay close attention to. This table is one that we need to learn and study. It's not something that comes easy to most people. So it's something we're going to need to work at. So we're going to work at translating English words into mathematics. So this is something you've probably done with numbers, but now the difference is we're also going to have variables in there as well. So we got these key phrases that we're going to try to recognize and remember. Addition, there are lots of words in the English language that mean addition. So sometimes we just say added to or plus, but sum is what we might see in a more mathematical expression. But in an everyday language, oftentimes we say we're totaling something when we say we're adding them. Or we say like 2 more years than that means add to or increased by. So mathematically we see the word sum, but in everyday language we might see total, more than, or increased by. Subtraction. In a mathematical sense, subtraction is often stated as the difference. The difference between or the difference of means the same thing, that we're subtracting. But we might also see less than or decreased by or less. And one of the things that can be confusing is that the order sometimes changes. So when we see subtracted from, that actually flips the order. So let me give you an idea. So if I say it's 2 subtracted from a number, that actually means x minus 2, right? That we don't put the 2 first because the subtracted from sort of flips that 2 to the back, which really gets sort of annoying because of subtraction, the order definitely matters. And that's where people sort of mess up the most, is putting the subtraction in the wrong order. But other than that, difference, you keep the order. It's just the subtracted from that we got to be on the lookout for. Multiplication. Mathematically, we'll see the word product, but in everyday language, oftentimes we'll see of. The word of by itself often indicates subtraction. Quotient is the mathematical way to say I want to do a division problem, but we might see ratio. The other word that sometimes gets used in everyday language is per for division. So let's try some of these, jump in, see how they go, and hopefully with some practice we'll keep getting better at them. So first example, the sum of a number and 2. So sum means to add. That's the first thing. We just have to have those memorized. We need to know that sum means addition. When we see a number, we're going to let that be x. So the sum of a number and 2 is x plus 2. Easy enough. As long as we know sum means add, that's not too difficult. Difference. What difference means is subtract. And one thing you can do if it helps you is just, if you know it's subtraction, we know there's going to be something before the subtraction sign and something after it, and we're just trying to fill in those boxes. In this case, what we're subtracting is a number, so that's x, and 10. So the difference between a number and 10 is x minus 10. One thing I want us to notice while we're here is that the word and doesn't mean anything, right? It's the number out in front that tells us what to do. The and is just a connection of what the two pieces are, but it's not telling us what symbol to put between there. Next one, 4 times a number. 4 times a number would be 4 times x. And remember, don't use the x for times anymore. You can use a dot or a star. Or we can just call this 4x for 4 times a number. But then I need to put the plus 5 on there. So whether you use a dot, a star, or just write it as 4x plus 5, that would be 4 times the number plus 5. So try this one on your own. You can pause the video and then come back and make sure you got it right. So let's see, this one says 8 times a number, so that's 8x, and then decreased by means subtract, so minus 3. Hopefully we all got that right, and this is starting to make sense. But really, it's just a matter of learning those key phrases like sum, difference, product, and quotient. So those were all expressions. Let's write those. So these are all expressions. If we want an equation, we need an equal sign. So expressions do not have an equal sign in them, and equations do. So in an equation, we need to have words that mean equals. So here are a variety of words that mean equals. We could actually say the word equals, but more likely, especially in everyday kind of context, we'll see is, was, or will be. So is present tense, was is past tense, will be is future tense, but they all sort of mean the same thing, that we're setting two things equal to each other. Represents, amounts to, sometimes gets used as well, but typically we'll see this is means equals. So let's try a couple examples. Write the sentence, the sum. So first thing to remember is sum means add. A number is our variable x. And is meaningless. So this says add a number and 11. So that would be x plus 11. And then is means equals, so equals 14. Last one, the quotient. For some reason, quotient really throws people off. We need to know it means divide. In algebra, we're going to use a fraction bar for division. Fraction bar for division. Not the divide by sign. So the division sign actually is meant to be a fraction bar with two pieces on top and bottom. I don't know if you ever knew that. We are going to stick with fraction bars for algebra. And I know that might take practice if we're used to using that division sign, but that's really not a symbol that gets used in algebra. So we want to try to get away from it as much as possible. So when it says quotient, what I'm going to do is write a fraction bar, and then we need to fill in what goes on the top and what goes on the bottom of that fraction bar. So let's read it. It says the quotient of a number means x, so that goes on the top, and 3. Remember, and is meaningless, it's just a joining word. 3 is the other piece of this quotient. So that's it, the quotient of a number and 3. What's not it? I'm missing the is 7. Is means equals, so equals 7. And we're not meant to solve it yet. Right now we're just practicing translating the English into algebra.